Okay, we are identifying factors of whole numbers, so let's get started. Now, the inside of the little booklet that I gave you, the one that we glued together, if you open it up, you've got a tree on the left-hand side that is titled as the factor tree. So what we need to do is we need to do the prime factorization of these numbers. So I like to do my factor trees like this. So I'm starting at the top here, and I say, what can I multiply to get 27? And I cannot use 1. So in my choice was 3 times 9. And I'm going to use a little dot, the little bullet operator is what we call it for a multiplication symbol, because it's faster, and this is what you're going to start seeing in 7th grade. So let's get used to that. So 3 is prime. 9 is composite, so 9 gets a little double split like that. So 3 falls down. And I can multiply 3 times 3 to get 9. Oops, 3 times 3. And so I've got 3 times 3 times 3 right there. And that's where I stop. So I can come down here and I can say that 27 is equal to 3 times 3 times 3. Again, that little dot is a bullet operator. It means multiply. Now, the other way that I could write that, so I'm going to put an or right here, is I could write 3 cubed, and that means the same thing as 3 times 3 times 3. So that's also something that's coming up. Okay, now let's do 81. I change colors here just for a little bit, just to have something a little different. Tell you what, let's stay with the tree motif and let's go brown. So 81, I'm going to split it up. Now, the way I would split it up to start off with is 9 times 9. Make that look like a 9 instead of a 1. So 9 is a composite number. It gets split like this, and it would be 3 times 3 times 3 times 3. So there is the prime factorization of 81. So 81 is 3 times 3 times 3 times 3. Or I could write that as 3 to the 4th power, which means 3 times 3 times 3 times 3. So there is that side. Now then you can color in the tree, make it look all pretty. There we go. Going to the other tab, it looks like this. This is a factor division ladder. So I haven't actually seen this one before, but it's a pretty ingenious little tool. So what we do is we say, well, what can I divide 84 by? Well, I can divide it by 2, because 2 is a prime number. So I pick out prime numbers that I can divide it by. And 2 times 42 is 84. Well, what prime number can I divide 42 by? Well, I can divide 42 by 2 also. And that would give me 21. And what prime number can I divide 21 by? Well, I can divide it by 3. And that would give me 7, which is a prime number. And I don't need to go any further. There's no more prime numbers. So this one would be what we would say is, it is 2 times 2 times 3 times 7. Or we could shorten that down. Now this is typically the way you would see it. You would see it 2 squared times 3 times 7. This is the way that you're typically going to see it. Now, you might say, well, I could have done this a little bit differently, like right here. After I did this first step and got 42, you might have said, well, you can divide 42 by 7, which is a prime number, and you're right. So if I would have done that, I would have gotten 6, which could be divided by 3 again, and that would give me, oops, I wouldn't need that part down there, but that would give me a prime number of 2. So it's 2 times 7 times 3 times 2, which is the same thing. So lots of different ways to do that. All right, now once you have your booklet all filled out, you're going to tape it up next to your I can statement. Now I think that I've got some pretty clear photos of that. And underneath your book, down towards the bottom of the page, and I'm just looking, I believe that's page 26 in your INB, in your interactive notebook. We're going to put these divisibility rules. Now, I'm not going to spend too long here, but these are the same rules that you used last year in 5th grade. They're the same rules that we've had for a while. Now, I did come up with one for 7, and it would be this. It says double the last digit and subtract it from the sum of the rest of the digits. Now, so on a number like 84, oops, I better get me a pencil to draw here. So let's say I've got a number like 84. What that means is if I double the last digit, so that would mean this is 8, and I subtract it from the rest of the digits, which would be 8. So 8 minus 8 is 0. So that means that number is divisible by 7. Now, you could also get 7 or a multiple of 7, which would also mean that that number is divisible by 7. So, for example, let's say that I've got, we'll try, let's see here, 80, no, I don't know that I can quite do this one. Let's see here. 805. We'll try that one. So if I double the 5, which would give me 10, and I subtracted it from the 8, so 8 minus 10, well, that's actually going to be what we call a -2, so that tells me that that one is actually not divisible. So there we go. So those are your divisibility rules. Pause it, copy it. You got the picture. Okay, so now I've got 216, this is the problem on the other page. This is the problem we pasted, at the top of page 27. And basically what we're trying to do is we are trying to find the factors of 216. So I'm going to look back at my divisibility rules and do this. Okay, so I know 1 is a factor. And as a matter of fact, I better follow my own advice, and I'm going to use the bullet operator because that's what you're going to see from here on out. So 1 times 216. Now, since this is an even number, I know that 2 is going to work. So if you know what half of 200 is, it is 100. Half of 16 is 8, so that would be 108. Now this is going to come into play in just a little bit, hit this 108. So now to see if 3 is a factor, add the digits. So 2 plus 1 is 3, plus 6 is 9. Oop, 9 is a multiple of 3, so 3 is going to work. Now, I would just kind of do a little bit of division in my head. I could actually come over here and do this. Okay, and I know that it's going to go in 7 times into 21 and 2 times into the 6. So that would be exactly what it is, 72. Now, 4 is, it says half the number is even. Well, the way I check, remember I said we were going to look at that? That's half the number. Well, looky there, it's even. So here's the other trick. If I cut that number in half, I'll know what number goes with 4. So half of 100 is 50. Half of 8 is 4, so it's 4 times 54. Now, 5, it says the number has a 5 or 0 in the ones place. No. 6, it is just both 2 and 3 are factors. Well, looky there, they are. Now then, if I cut this number with 3 in half, that should be the number that works with 6. So half of 70 is 35. Half of 2 is 1, so that would be 36. That should work right there. Now then, 7, if I double the 6 and get 12, 21 minus 12 is 8, so 7 is not going to work. 8 is going to work. It'd be 8 times 27, 9 times 24,